Okay, so the next example relates to understanding what we do with these variables once we've started to work with them. And to understand a variable, we have to first understand what a quantity is. So let's start with that. A quantity describes an amount of something that we define. So here I have 2 squares. The number 2 is the quantity. Squares describes what it is that we're quantifying. A variable describes something that we don't know until it is defined. So this box here could represent a variable. We don't know what's in the box, we don't know the quantity in the box, we just know it's a box. Now the important thing in algebra is that if we call it a box, if we refer to any other boxes with the same name, it has the same quantity inside it. So imagine each box is filled with the same number of pencils. Here's a box full of pencils. Here are 2 boxes filled with the same number of pencils. Here are 3 boxes with the same number of pencils. Now here's the question. How many pencils do we have? Well, I haven't told you yet. All I know is that I have 3 boxes of pencils, and that each box has the same number of pencils in them. So once we're told how many pencils are in each box, we can start to work with it. But before we do that, we can use algebra to describe what we have a little bit easier. So here's 3 boxes, and we could say that that's 3 lots of boxes. 1 box, 2 boxes, 3 lots. 3 lots of that makes 3 boxes. Now, in algebra, we typically don't write the multiplication symbol, and we shorten our variable names down because we're a bit slack, to be honest. So instead of writing 3 boxes, we might write 3b. I'll underline where I'm up to. Over here. 3 lots of boxes is equal to 3b. The b represents a box, and this is saying we've got 3 lots of boxes. 1, 2, 3. Now, once we've understood the language of algebra, we can now start to do something with it. So in this case, let's say that each box has 10 pencils in it. So if we have 3 boxes, we have 3 lots of boxes. And in each lot of boxes, in those 3 lots, we have 10 pencils in them. So that gives us 3 lots of 10 pencils, or 30 pencils. Now, algebraically, we could say that a little bit simpler. We could say, let b, our variable, equal 10 pencils. And wherever we have a b, instead we're going to write 10. So here we go. We have 3 lots of b. That's what 3b means. And if I write that over here, instead of saying 3 times b, I'm going to say 3 times 10, because each box has 10 pencils in it. 3 times 10, which gives me a grand total of 30 pencils. Let's look at another example. Let's imagine we had small boxes, and each small box had 10 pencils in it, and each big box had 50 pencils in it. So I'm going to let the variable s represent small boxes, and the variable b represent big boxes. And the question is, if we had 3 small boxes and 4 big boxes, what would that look like algebraically? Well, I suppose I've just said it, haven't I? So we would have 3 lots of 10 pencils, because each small box has 10 pencils in it. Small box has 10 pencils. And we'd have 3 lots of 10 pencils with our 3 small boxes. And our big boxes have 50 pencils in it. And we've got 4 big boxes, so we would have 4 lots of 50 pencils. Writing that out algebraically, 3 small boxes plus 4 big boxes would be 3 lots of 10 pencils plus 4 lots of 50 pencils, which would give me 3 times 10 is 30, and 4 times 50 is 200, for a total of 230 pencils. So in 3 small boxes and 4 big boxes, this part here, we have a grand total of 230 pencils total. And that's pretty much all I want you to do today. So if you have a read through that and have a look at the worksheet that I've put after it. See if you can answer those questions. Thank you.